Hello everyone, and welcome to lesson 7.4, which is on function notation. Now, we have seen function notation off and on all semester, and we have explained it before, but we're going to take a little bit of extra time here to explain it again, and we're also going to take a look at how to solve problems using function notation. So, where we're going to start is back in chapter 3 when we were talking about expressions, and we did a lot of stuff with substitution. So if we remember back in those earlier chapters, we had equations like y equals 2x plus 3, and then we would give you what x would be equal to. We'd say x is equal to 5. Well, we knew then that all we had to do was take our 5 and we just plug it in for x. Right, and we covered that. So then we end up rewriting the equation with the 5 plugged in, and we solve, right? 5 times 2 is 10. 10 plus 3 is 13. And we get our answer, right? No big deal. We know how to do that. Well, now we have our function notation. So again, we see this term right here. First off, this term is read as f of x. That's how we would read that. That is not a weird f times x situation, right? F of x stands for basically a function whose variable is x, is really the long way to write that, but the short way to say it is just f of x, and what we know is f of x is really, it's really just y, right? So essentially, me using a different notation, f of x and y, they're the same thing. Now, whenever we get this equation, notice that our equation for the problem, 2x plus 3, it's the same. We know that f of x and y are the same, so we essentially have the same problem. But now we are looking at this piece, which we would read as f of 5, and this basically is telling us what to plug in. So all we're going to do is we are going to take this 5 and we are going to plug it in for x. It is a new fancy way of having us do the exact same stuff that we always knew what to do. When we see a number in parentheses, we go back to the equation that has the x in it, we plug it in. No big deal, nothing different. And all we would say is when we write that out, we would just say, hey, cool, f of 5. So if I'm plugging 5 in, it'll look like this. And when I solve that out, that ends up getting 10 plus 3, which ends up being 13. And that's our answer. You could also even, if I go back a second, you could also even just say, hey, f of 5 is equal to 13, which we know, like we said, f of x and y are the same thing. F of 5 is what we get when we plug in 5 to the equation. We get 13 out. Notice that these answers are exactly the same. So, we essentially have the same problem written out twice. One is the old way, one is the new way with functions that you'll see in chapter 7. You'll see a little bit in chapter 8 as well. But we just need to know what the notation means and what the problem is asking us to do. And essentially, if we see a number in parentheses with the f in front of it, so f of 5, f of negative 2, f of 17, we're just taking the number in the parentheses and plugging it back into the original problem. All right, that's it. So let's look at some examples here. We got 4 of them in this section. So our first one says f of x is equal to negative x minus 5. evaluate f of 3 and f of negative 7. So for our first part, all we're going to do is we're going to evaluate what f of 3 is. What happens when we plug 3 into our equation? Well, if I plug 3 into the original equation, I get negative 3 minus 5. Well, negative 3 minus 5 is negative 8. So there's our first piece. The second one, what happens if I plug negative 7 in? Well, that would give me negative 7 minus 5. We know that two negatives there end up making a positive, so we end up getting 7 minus 5, which is 2. Right? And that's all we got to do. We're not doing anything fancy. We don't have to do anything fancy with the 3 or do some crazy division or anything like that. We're just taking the number that's in the parenthesis, plugging it into the equation, and simplifying. All right. Even if we get a tougher problem with multiple x's in it and division and all this stuff, we still don't do anything crazy. All we're going to do is we're going to take the number in the parentheses and plug it in for our variable. So, in this problem, if I wanted to find out what f of 2 was, all I would do is I would plug in 2 anywhere there was an x in the original problem. So 3 times 2 plus 1 divided by 5 times 2 minus 5. Now, when we solve these, let's simplify the numerator, right? Which is 3 times 2, which is 6, plus 1. We can simplify the denominator. 5 times 2 is 10, minus 5. Keep going. 6 plus 1 on top is 7. 10 minus 5 on the bottom is 5. And our answer is 7/5. Just because there are multiple x's doesn't mean we do anything crazy. All right. Our third function that we get is w of t is equal to 9t minus 5. Now, w of t is nothing. It's just the same as f of x. They're just two different letters and two different variables that we're using. So you don't worry about that. So w of t is equal to 9t minus 5. It tells me that t is actually equal to 1/3. So again, all we have to do to solve this is we're going to plug 1/3 in for t and solve. That's going to end up giving me 9 times 1/3. It's the same thing as 9 divided by 3, which is 3. And then we say 3 minus 5. 3 minus 5 is negative 2. So, same type of problem, even though it looks kind of different way to write things and express things, we're still doing the same math. All right, the last one says a of z is equal to 20z minus 7. Evaluate a of negative 1/4. So again, same type of problem. A of negative 1/4, we're going to plug in 1/4 anywhere there was a z in the original problem. So 20 times negative 1/4 minus 7. 20 times negative 1/4 is negative 5. Negative 5 minus 7 is negative 12. Okay, so after a long lesson in 7.2, getting a little shorter in 7.3, now we've hit 7.4 with stuff that we've kind of seen before, but we can take a little more time to break down. Just know, with function notation, the numbers inside the parenthesis, we just got to plug back into the original equation and simplify. Hopefully this has helped you with problems that you'll see in lesson 7.4, but as always, if you get stuck on anything, if you have any questions, please reach out to me and let me know.